Okay, in this question we're asked about the weights of 3-year-old boys roughly fit a normal distribution with this particular mean and this particular standard deviation. If a 3-year-old boy and girl are picked by a car fitted with car seats suitable for children up to 16 kilograms, what is the probability only one of them will be light enough to fit the fitted seats? Now it's important that we remember the information from the previous question about the girls, where their mean was 13.8 kilograms and their standard deviation was 3.4 kilograms. So in this particular case here, step one is to find the probability that x is greater than 16 for the girls, and to do the same for the boys. So to find probability of x is greater than 16. So we'll do that first. So basically, if we were to draw our diagrams, what we're looking at here is if we've got our mean, 16 is obviously bigger than the mean on both cases. We're looking for that probability. From there we're going to draw a tree diagram and work out the last part of the question. But first of all, we need to find out what the probability is that they are heavier or lighter, for that matter, than the 16 degrees. So I'm going to do heavier in this case. So we'll actually start off with the boys. So we go distribution, normal, NCD, and we'll put in our lower value of 16 in this case here. So I've done that, and we'll put in our upper something ridiculous, like 1,000, and then we'll put in our standard deviation of 3.6 and our mean of 14.4. And what that does is that shows we have a probability of 0.3284 if I round it. So if I write down here, probability for the boys being greater than 16 is 0.3284. Okay, and we'll now go over to the calculator and we'll check out the girls using the information we got from the previous question. So it's simply a case of working our way back. Now we're going to work out what the girls are. So we go back onto the screen using our calculator. We'll go back up and we'll just change the standard deviation to 3.4, which is for the girls, and the mean is 13.8. Do that, and we find out that our probability is 0.2588. So we'll do that. 0, so I'll just put that up here, equals 0.2588. Okay. So at this point, it's also probably a good idea that we work out what the probability is that x is less than 16. Now, this is obviously just the complementary to these ones here. So for the girls, that would be 0.7412. And for the boys, the probability of x is less than 16 would be equal to 0.6716. Okay, so what we're going to do now is we're going to create ourselves a bit of a tree diagram, because what we're trying to find out is what is the probability that only one of them will be light enough to travel in the fitted seats. So basically we're either going to have a situation where both girls, both girl and boy are light enough, where they're both not light enough, or one or the other is. So let's draw a tree diagram, and you probably aren't that familiar with tree diagrams, some of you. But so let's do the boys first. First enough, the boys light enough, boy heavy. Okay, so too heavy for the car seat. So if they're light enough for the boys, that's, I'll just put the probability here, 0.6716, and if they're too heavy, it's 0.3284. Okay, and for the girls, we just then do a branch off each of these. They're all tree diagrams. Some of you would have learnt this at level 2. So here we've got girls are light enough, girl heavy, girl light, girl heavy. Now you can do this either way. You could do the girls first and then the boys second. It doesn't really matter. So for the girls to be light enough, that would be 0.7412, and that's the same down here, 7412. And if they're too light, too heavy, sorry, 0.2588, 0.2588. So what we have to look at here is what are the options for where only one of them will be light enough to fit in the travel seats. So if we work our way up the first branch here, so this one here, that's where the boy is light. Now if the girl is light, that doesn't meet the requirements of the question where only one of them is light enough. So we could have boy light, girl heavy. So that's this probability here. And the other option is where we've got where the boy is heavy but the girl is light. So that is this option here. Now the way we work it out is that we multiply down the branches of each option and add them together. So this is what you'll get. For the first one, that would be 0.6716 times 0.2588. And on the second one here, it's 0.3284 times 0.7412. So on our calculator, if we had multiplied those two together, we would have got, so 0.6716 times 0.2188, that equals 0.1738. Oops, I'm pressing the wrong button here. And this one down here is 0.2434. So now we add those two together basically. That's how you work the tree diagrams, and we end up with 0.4172. So we can say that the probability of only one of either boy or girl being light enough is 0.4172. Now you could convert that to a percentage, even though they haven't asked for a percentage. I'll just put it down there, or 41.72% chance. And that's how you do that particular question. And wait for it, the grade for that is a T if you can complete it all the way. There is a possibility of getting an R if you're able to do some part working along the way, but that's really up to a marker's choice. But the whole question as a whole is worth a T.